Hello everyone. Today we've got an unexpected repair video. It's something that happens to everyone that does electronics repairs. Every now and then you have to repair your tools. I was working on a MacBook earlier, and as it happened I was measuring something inside, and next thing I hear this bang and hiss, and I thought that was the end of the MacBook. But it turned out it was the power supply. So is one of my power supplies, my secondary one, and let me just show you what's happening. So if I turn the supply on, there you go. This is supposed to be a 30. See, this channel is working. Let me turn it the right way up. Okay, this channel is adjusting okay, and it's supposed to be a 30 volts supply with 5 amps. Yeah, it's all working. This channel is going to 50 volts, and that's it. It's not adjusting anything. Luckily nothing was plugged in, so I took the screws off. Let's take the cover off and see where we are with it. Okay, here we go. Don't know if any of you got one of these. You can do, like, I put a knock to off and a silent one. I replaced the original one. I had to get some longer screws because this had a different type of fitting. But anyway, it's very quiet now. You can't hear a thing. So I wish I filmed it when I done it. So, oh, I can see something straight away. Look at that. Let me just turn the microscope on. Okay, let's switch to the microscope. Can I show you this? Well, if you see there's a capacitor on the output that's really puffed up. Let's have a look. If I zoom in a bit. Okay, that capacitor there, that's the one that's blown out, but I presume that's blown because the voltage went to 52, and now I presume his voltage is less than that. We've got, from what I can see here, 2 separate channels on the power. Let's try to check which one actually goes there. Lighting is not very good. Inside here, I hope you can see. Let's see, gray and blue. Where does it go? Gray and blue goes down here. Yellow and orange. So this side of the power supply, this is our output. So let's see, let's measure what we've got here. I'm gonna plug it in. And we do have 52 volts. Okay, what we need to do, we're gonna need to take this board out and have a look. Okay, I'm gonna save you dismantling. I'll pause the video. Before I dismantle, I decided let's have a quick stab at it like that before we dismantle everything. Maybe we can quickly find something. Well, let's take the capacitor off. I'm going to switch to the microscope. Of course, it's all twisted and see if we can do it. Alexa, turn the extractor on.
Okay.
Let's see how badly this goes. So I presume all them wires are gonna pop off as soon as I try to pull on this. Why don't just cut it? Okay, the whole thing is coming off. Maybe that's for the best. Okay. I guess the wires are staying. I could have done a bit of a better job, but I didn't know how they soldered in there. Let's try to push this back in. I'm gonna make it pretty again at the end. But for now, let's just push this in. Alright. Now let's try to untangle all this. And now I'm gonna do. I use a bit of solder wick. Sorry, I'm focusing on this because it's burning my fingers. Let me get this out of the way and keep on forgetting that these videos are meant to be watched by other people. I keep focusing on what I'm doing and forget about the camera and that. So try to get this a bit more focused. Get as much of this solder off. Let's see if that works. gonna try to unwind this. There we go. Okay, one side is done. Now all we need is to heat up the other side, and hopefully that will just fall through. No? Yes, it did. How was it? Try to remember the position. We're gonna check that diet. So 470 micro at 35 volts. Let's see what we've got. Might have some of this. Let me double check. Okay, I've got 470 at 50 volts. So I think I'm gonna take this opportunity to replace the other one. But yeah. Let's measure that diode before we do anything else. Alexa, turn the extractor off.
Okay.
Yeah, the diode seems okay. This is how it went, if I remember correctly. Let's go into my skin. Let's get it as nice as we can. Maybe I should have zoomed out a bit, but not much of a difference now. Okay. Alright, soldering time. Double check on the other one. Yeah, we're right with the positioning. Alexa, turn the extractor on.
Okay.
Alright, look at that, not even new. Yeah, look, this is good. Okay, perfect. Let me put Alexa, turn the extractor off.
Okay.
Let me get the thing back on the desk. Okay, let's solder this back. And hopefully we can manage to fix this before I'm going to put it back together. I'm going to change the capacitor on the other one. Okay. Yeah, flux. Wrong way. Good thing I checked. Always double check, triple check before you put it the wrong way around and you release the magic smoke. Alexa, turn the extractor on.
Okay.
Let's clean up a bit. Like the plastic melted a bit, but hey, it's all good. Well, now let's check what the problem is. Alexa, turn the extractor off. Alexa, turn the extractor off.
Okay.
Now we need to check, probably switch to the, better to switch to the overhead camera. Okay. This is so these are the manual controls, but the actual switching is happening on this. So let's see what these two components are. I didn't check them. It could be triacs, transistors, whatever. I don't know, it says E7 or U7, whatever. I can't see, but I don't want to bend the pins. I'll turn it around and I'll have a look. Let's switch to the microscope. Let's switch to the microscope. Okay. We have that. BU406. That seems a transistor. The old BUs from the old times when I used to fix TVs, the big old TVs. CRT TVs. Let's try to find it. Right. So we said NPN for the base. You can't see my multimeter, but that seems to be okay. That seems to be okay. Oh, that's collector emitter. We've got two ohms roughly. Well, I'm on diode mode, but yeah, both directions. Actually, like this, yeah. Let's try this one. Do I have the same? No. No, there's not short circuit over collector and emitter. Let's take it up and measure it outside. Oh man, I'm gonna rip some of these wires soon. Make sure they're clean all the way, because without the microscope I can't see. Yeah. Both good. All three, sorry, good. Let's get this out of the way. And let's check the transistor. Let's get the microscope back into play. get some proper lighting. Stop messing about with the go default for a second. That wasn't good. That's better. Okay. Let's see if we still have a short here. They will say that's okay. Don't have a short anymore. So the short is on the board. Let's check if everything is okay. Yeah. Alexa, turn the extractor off.
Okay.
Now you can't see the multimeter, but everything is showing okay. Now on this transistor. So let's clean it up a bit and let's check the board. Oh man, I really don't want to take the board out. It's got so many wires soldered to it. Just cleaning the transistor. So I can get it back into the to make it easier to put through the holes. Alright, so on one hand I'm happy that's good because I didn't have one in stock. On the other hand, let's see what's short here. Okay. Switching cameras again. Must have got you dizzy by now. Very bad lighting, I know. I just rushed it to start the video. Okay. Got a bit of a plastic thing here that I don't know where it's coming from. Oh yeah, I know, it's okay. It's from one of the negative plugs on the front. Okay. Oh, and it's the thread on that. It's gone. And let's see if we can check where this is going. Okay, that's not very good. White and red. Well, this wire is going. There's two wires going from there. If I can zoom in more. Okay. Okay, so what's happening? We've got a short here. Let's double check. Yeah, that and that. No, and that. Sorry. So there's the red and white wires that go to the fan. And Okay, I think this is where our proper power control is. Okay, but on one hand is good. Let me put that transistor back because I don't think the fault is. We have somewhere here under the fan, we have the main power control semiconductors, whatever they are. Okay, let me solder that transistor back. Let's quickly get a bit of solder onto it, and then I'll bring it over. Okay, soldered one of the pins just quickly before we do everything. Right, the schematic would have helped, but we don't have one, so we play the cards we've been dealt. Okay, that's that, and let's see what blew up on this side. Right, I guess the fan has to come off. There we go. This is what it is. Knock to INF A9 Y14, whatever, X14. If you get one of them, you'll just have to change the screws to fit, but it's a direct swap. Can't remember if I had to modify the connector a bit or not. I'll show you in a second. Let's take the whole thing out. This is the connector. I can't remember if I had to solder a new connector or if that was the connector that was on there, but hey, you might have to solder a normal connector for a fan. Very common. You can find it on boards. And okay, let me clean this a bit because I don't want to get all that on my hands. USB 5200, I think. Let's see. Let's try to find it. Actually, let's see if that's short first before we. Right. Let's take it out of here and get this out of the way. So. and this out. Measure it now out of the check if the short on that on the board is gone. Yeah. Let me make sure the other one. Yeah, everything is good. Well, let's try to find one of these. Okay, I found them at CPC UK, which is part of Farnell Group. Two of them with the delivery and VAT cost about £14.45. So let's order them, and we'll carry on with this video when they come in. Okay, it's Monday now, and I had these transistors delivered. From what I read on the data sheet, these are slightly more powerful than the ones I've got in. The ones that are in, the 200 rated at 230 volts, 15 amps, and the ones I got, the new ones, they rated 250 at 17 amps. So 230 at 15, the old ones, 250 at 17 amps, the new ones. So yeah, I think I'm gonna replace them both, just to make sure I don't have to open this power supply for years to come, hopefully. I'm also gonna change the second capacitor, the one we changed on the previous part of the video, which is hanging about here. I left it inside. There you go. Okay, let's try to remember where we were with this. Okay, this is where we were. Let's clean up the thing. We're gonna take the other one out as well, and then we clean up the holes and fit the new ones in. Okay, that's all done. Let's clean it up a bit. Probably wondering why I've got tissue underneath all the time. What I'd like to do is to spray the alcohol, and when the toothbrush gets on the tissue, it leaves all the flux on there, so I don't have to. Basically, the toothbrush takes the flux off, and you don't just keep rubbing it onto the board and spread it everywhere. This works for me. I'm not suggesting you should use my method, but I was just explaining in case you're wondering why am I doing that. try this now. Alexa, turn the extractor off.
Okay.
Right, you're gonna need to. I don't know if you can see. We've got the two. Okay, the two insulation bits that go between the transistor and the case. What I'm gonna do, I'm gonna clean all the old thermal paste and put new thermal paste everywhere, make it all nice. Okay, give it the best chance to be as cool as we can get it. Okay, these are done. Let's get some thermal paste. Apply some on the case. To the bottom of it. Try to get it on the actual. Alright, a bit too much. Going all over the place. Never mind. Can recover that. There you go. Probably can't see anything down there, but yeah, I'm just applying thermal paste with nothing. Nothing special, nothing highly technical. There we go. I think the bit is done. Let's apply some on the transistors. Put a bit on the actual pads, and then I guess we can screw it in. Try to get all the bits and pieces that I need. There. Last time I've been in this, let me get the screws. I put some thermal paste on the front of the transistors as well, between this heatsink and the front of the transistor. Don't know how much that helps, but yeah, probably I'm gonna do it again. Try to get this in. And make sure them maybe you should see what I'm doing as well. Make sure the insulation pads are lined up nicely. We don't want the transistor touching the case. Alright, so let's see a bit of this. Come on. There we go. Now how do these go? Like that. Okay, much as I want you to see that, I need a better positioning. All right. I can't hold it up like that. And, try with the second one. No, I still can't hold it like this because I need room to put the screwdriver behind. I might even speed up through all this. That one's in. Just make sure they're tight enough. Get that thermal paste to spread. Okay, now this is gonna be a job and a half, remembering how all this I put loads of washers and things in last time I fitted this. I don't know why, but must have had a reason last time, so I'm gonna try to work out what the reason was. Let's get the fan, plug it in. Wonder if we should try it on before we do anything else. As far as I'm concerned, everything is in working order now. Oh well, let's have a go. Alright. Okay, let's see. It's adjusting. Hey, all good. The relays are clicking. Yeah, nice. Oh, it's not jumping up and down. Jumping up and down when I lift it up. Why? When I put it down. Nice. It's steady only when I lift it up. Is it because this board is not screwed on? Probably I'm moving this cable. Alright, the fan started. Let's try to keep this board steady. Yeah, it looks okay. Alright. Our watch keeps going off. Let's quickly check if we've got the right voltage. 0.1 of a volt difference. We're good. Let's put it back together and we're gonna do some more testing at the end. Alright, we'll put it all back together and back in its place. I set up some kind of rig so we can see it's all working fine. And let's switch to the hand camera. Okay, what I've done, I just plugged the power bank on charge with a little board that converts the power from DC jack to PD power delivery in USB-C. So I set up my multimeter, and yeah, somebody asked me why am I using a crap multimeter. There's a good reason for that. The multimeter belonged to my dad, and when he passed away I took it and I'm gonna use it till I can't use it anymore. Basically, it's got a sentimental value for me. So yeah, it's all broken. I repaired the back of it and all that, but I'm still gonna use it. When it becomes not accurate anymore or something wrong with it, then I'll stop using it. But anyway, I rigged it all up so we can see the voltage, the current. Let's see if there you go. Current limit clicks in, so it's all good. Let's see if the voltage is yeah. Sorry about this. The hotel station is in the way. Hold it with the other hand. I'm making a mess of this. It must be used by now. For the way must be used to it. For the way I work the cameras. Right. Yeah, it's pretty spot on. Yeah, I don't need it more accurate than that. Got another power supply. Alright, now you're gonna see the mess on my desk, on my bench. There you go. I've got that, which I use most of the time for laptops and stuff. I've got the sorry, I have 140 watts PD power supply that comes for laptops and other stuff, and I use this USB-C meter with it, but now I took it off to show that you're probably getting dizzy with this hand camera. Anyway, it's all working. Thank you very much for watching, and I'll see you on the next one.